Welcome. Today we're going to introduce the point-slope form of a linear equation. But as a quick review, we've learned the slope-intercept form, which is y equals mx plus b, where m is the slope of the line. This b value is the y-intercept. We've also just recently learned standard form. Standard form, it's written as an ax plus by equals c, where all of a, b, and c are integers, and a must be positive or greater than or equal to 0. Again, refer to our last lessons if you want more review on those. But today we're going to talk about what's called point-slope form. Point-slope form looks like y minus y1 equals m parentheses x minus x1, where m, just like in point-slope form, is the slope, and this y with the little subscript of 1 and the x with the little subscript of 1 is a point, x1, y1, that is on the line. As a quick example, and again, if you need to, take a minute to write that down and think through what I just said about each step. But as an example, actually, let's make sure it's visible so you can at least see the formula. I'm going to do this. Y minus 4 equals 2/3 parentheses x plus 5. Now, what that tells us is that this line has a slope of 2/3. So its m value is 2/3. So I'm going to go up 2, right 3, up 2, right 3, right? And I go through the point 4, -5. Now let me explain why, oops, you can't quite see that, why it's -5 when this is plus, why it's +4 when it's negative. The reason is a point is an x and y value that makes the equation true. Well, what value of y, when I minus 4, will make this side 0? Well, a +4. You think about this, 4 minus 4 is 0. Well, what happens to this side if I put a -5 here? -5 plus 5 is 0, and I'm going to times that 0 times 2/3, and 0 times 2/3 is 0. Well, does 0 equal 0? Yes, that means that statement is true for the point 4, -5. So it's always the opposite of what you see, because you want a value of x that when you add 5, that becomes 0, and when you want a value of y that when you minus 4, that becomes 0. So let's quickly look at, if I can get this to switch back. There we go. I want to go back to here. Don't even need this. Here is what you're going to be doing. You're going to be given this equation, and you're going to be asked to graph it. Well, the first thing I want you to do is ask yourself, what value of y when I add 3 is 0? Well, that value would be a -3. So again, that tells me I have a y value of -3 when x, what value of x when I plug in here -1 gives me 0? Well, that would be a +1 when x is +1. So I go through the point 1, -3. So go over here to +1, down to -3, and I graph that point. Now, this point right here is the slope. Remember, slope is always thought of as a fraction, so the slope is a -5 over +1, or I could do a +5 over a -1. Either one works. Since the slope's negative, only one of them is negative. So I'm going to, from this point, I'm either going to go down 1, 2, 3, 4, 5, and right 1, or I could go up 1, 2, 3, 4, 5, and left 1. And I've graphed my point. So this will become easier and easier the more you do. So again, this is in point-slope form. And what makes it a little bit confusing maybe for you is you're like, well, there's no plus or minus here. Well, I could rewrite this as y plus 3 equals 4 parentheses x minus 0. In other words, if you don't need to write the minus 0. So if you don't see parentheses and thing, that just means the x value is going to be 0. And what value of y will make the left side 0? Well, that's going to be a negative 3. So I go through the point 0, negative 3. So again, grab my cursor, go to right there, 0, negative 3. My slope is 4, so I'm going to go up 4 and no right 1, or I would go down 4 and left 1 and graph my line. Again, here, my x value will be negative 7. My y value will be positive 6. So I go to that point of negative 7, positive 6. And then I follow my slope of, now remember, if you don't see a number, there's actually a 1 there. It's negative 1. So that's either negative 1 over positive 1, or it's positive 1 over negative 1. So I follow my slope from this point of going up 1, left 1, or down 1, right 1, going downhill slope, and I've graphed my line. So again, you'll get, so you can actually do this without doing any math at all. Without any writing anything down, I just realized that negative 3 plus 3 will be 0. So I'm going to go over to negative 3, and then positive 6 minus 6 will be 0. So negative 3, positive 6 is where I'm going to start. Slope is 3, so I go up 1, 2, 3, and right 1, or I could go down 3 and left 1. If you have any questions on these, please bring them to class. But all of them will be exactly that simple. And in other words, I'm going to go to an x value of positive 4, a y value of positive 5, slope of negative 3/4. That means I'm going to go down 3, right 4, or I'll go up 3, left 4 to that point. Either one works. And we're graphing these lines. So they all should be very, very simple once you grasp the concept that you take not negative 30, but positive 30, not negative 60, but positive 60. So I'm graphing that point 30, 60, and then I'm going to do a slope of negative 4. Now, watch your scaling, but as long as the scaling is by tens on both axes, I could go up 40 and right 10. Oh, it's a negative slope. I'd go left 10. Watch your slope. See, I thought about that little guy, and he was going to be going the wrong way. So I'm going to go down 40 and right 10, because 40 over 10 is still 4. Again, have questions, please bring them to class, and I will help you then.